Welcome. This is Raymond.
And Walker.
And today
Hello.
we're going to teach you a little bit more about imaginary numbers, and we're going to introduce complex numbers. Now, complex numbers are useful because they teach us something about the distributive property. Now, you may have learned the distributive property when you were working with multiplying fractions, right? You remember how to do this? How would you do this multiplying fractions using the distributive property? 1 plus a half plus 3 times 3 is equal to,
You would multiply 1 times 3,
mm-hmm.
and then that would be 3, and then you would multiply 3 times 1/2 would be 1.5. So you would get 4.5.
All right, 4.5. Okay. Now, I might argue that it was easier to simplify what was inside the parentheses when we're doing distribution that way. Now, later on in high school, they're going to teach you to do 1 plus x times 3. And of course, that's going to be 3 plus 3x. And you use the distributive for that. But sometimes that's a little hard to do because x is unknown. Well, today we're going to do something that involves complex numbers. 1 plus I times 3, which of course is equal to 3 plus 3i.
Interesting.
The product of a real number and a complex number is going to be a complex number. But I'm going to show... Well, this is a complex number, 1 plus I. Okay, it looks like the sum of a real number and imaginary number, but I'm going to treat that as a number together when you have a real and an imaginary. We're going to call them components.
So what you're saying is when you take a complex number and it would make a complex number when you take a real number and an imaginary number.
That's right, and you add them together.
Oh,
but when you take the product of a complex number and a real number, you get another complex number.
Okay, that makes sense.
It turns out that when you start multiplying complex numbers, it can get pretty
complex.
That's right. Now I'm going to show you something that is a really tough number to multiply. And we're going to figure out what the square is of square root of 2 over 2 plus square root of 2 over 2 times I. And that's a very important, what's inside the parentheses is a very important root that you're going to learn. Of course, we do this by, let's multiply it out, plus square root of 2 over 2i. Do you remember what the method is when we have a distributive problem like this? It's got a special 4 letters when we have the product of 2 pairs of sums there. Do you remember what that initials are? One of the letters is F.
F. O. L. I.
Foil.
L. Foil.
And that stands for first, outer, inner, and last.
Last, yeah.
Okay,
last.
We're going to do the FOIL problem, and I'm going to let you work it. We're going to take that product, and we're going to divide it into 4 simple products, doing the first, outer, inner, and last. And I'm teaching you this with complex numbers, because I think it'll be easier for you later on. Learning it with these complex numbers will be it's going to be a cinch. Okay, so let's think about what we're going to do for first. First is going to be
Excuse me?
This times this.
Okay.
And do you want to do it in black or do you want to do it in red?
I'll do it in green.
In green, because you like green. Go ahead and
not
show me what the square root of 2.
Lime
green. Okay. Square root of 2 over 2 times square root of 2 over 2. Why don't you just write out that product? Can you write it out in that box?
Square root of 2 over 2
times
times
square root of 2 over 2.
Square root of 2 over 2. This is hard.
Okay. Well, it's not that hard because when you have when you have a fraction times a fraction, and you're taking the product, you multiply the numerators, and then you multiply the
denominators.
Right, and
the denominators.
So that one is going to be square root of 2 over 2, square root of 2 times square root of 2, which of course is, what's the square root of anything times itself?
Square root of anything times itself.
It's going to be the anything, right?
Yeah.
Okay.
Because
so what's square root of 2 times square root of 2?
Square root of 2 times square root of 2 would be 2, because
That's right.
You would take the square root of 2 and another square root of 2, and since it's the square root of 2, you would multiply the square root of 2 times the square root of 2, and you would get 2.
Okay, what about
Sorry
multiplying?
if that was kind of confusing.
No, you did great. What about multiplying those denominators? 2 times 2 is going to give you
4.
4. Okay.
Right.
Now we could simplify this first term because 2 over 4 is really just a half. But let's not bother simplifying, because sometimes you make some mistakes simplifying and then you find out later on that you could have done better.
Okay,
Let's do the next term.
Next term.
Which of course is the outer. Okay. That's going to be, I'm going to draw it for you, square root of 2 over 2 times square root of 2 over 2 I. Now why don't you help me multiply that out? Talk it out and I'll write it down. What about square root of 2 times square root of 2?
That wouldn't that be, yeah, that would be 2.
And what's the denominator?
4.
4, okay, but
and
we've got that
I.
Okay.
So let's save the I.
We keep the I there. This is, yeah, we could put it on the numerator, or we can just put it right after there because it's a product. Okay, it's 2/4 of I. We're going to do another one. We're going to do
another one.
We're going to do inner.
Oh yeah, inner.
Because this is FOIL. And the inner is going to be square root of 2 over 2I times square root of 2 over 2. Now remember, we can move multiplication. We can move the I outside of that, so don't let that bother you too much.
Okay.
What is the numerator going to be?
The numerator is going to be 2 again.
Mm-hmm. What's the denominator going to be?
4.
4. And we can just move that I round to the outside, and it becomes
2/4 I.
Isn't that interesting? We only got a couple of those now.
So you'd have to add all of them?
We're going to have to add them. Let's do the last. Last is going to be that and that. And last is where we're going to come in and use what we learned last time about what I times I is. Let's
I
see
times I, if I remember correctly, it's -1.
That's right, because I is the square root of -1. And that's actually, this is the first time we're using that in these complex numbers. Up until now, we didn't really need to know that I was the imaginary number. This was the same as if we were doing algebra, but with complex numbers, we can make the simplification. We see that the numerator is going to be...
The numerator is going to be, as usual, 2.
And the denominator is 4. And now we've got the I times I.
And I times I would be
I squared
-1.
is -1.
And like 1, it would be the same thing. But -1, wouldn't you just add a minus sign?
Yes, we can put a minus sign in front of that and say it is -2/4. That's correct.
Okay.
Now we're going to do the simplification, and I think it really worked out that we didn't do too much simplifying of the fractions, because now we can group these terms together. It turns out that the two real terms, 2/4 and -2/4, are going to
since they're the same number, right? Except for the positive and negative.
Yeah,
you would cancel them out.
Now this one is going to simplify quite a bit. What about 2/4 plus 2/4?
2/4 plus 2/4, wouldn't that be 1?
That's right. It's 4/4 or 1. And you still got the I on both of them, so you group the like terms. And you've got 1 times I.
Cool.
Okay, so what we just did was we did this complicated product equal to I. But do you remember that this product was a square? It was a perfect square. Now, if we know, let's create ourselves a little bit of room here. Let's just get rid of this. Isn't that neat that you can do that?
Bye-bye.
Let's give ourselves a little bit room on the chalkboard. If we know that square root of 2 over 2 plus square root of 2 over 2i squared is equal to I, then I have a really tough question for you. What is square root of 2 over 2 plus square root of 2 over 2i without squaring it? If squared is going to be equal to I, what if you don't square it? What do you think you're going to get?
That's hard.
Well, it's going to be the square root of what's on there.
Yeah, so square root of I would be negative I, because...
No, it's...
What?
Square root of I is not negative I.
Oh, it isn't? Great.
No, the square root of I
Got it
is
wrong.
not pure imaginary. The square root of I is...
This is confusing.
No, it's not confusing. It's complex.
Yes, it is. Oh, okay. Same thing. No, I'm kidding.